Well, hello, welcome. This is my presentation for the first ever virtual NCECA conference. And I'm so delighted you're here. And let's just jump right in. I have a concept for a weightless color blending technique that involves using jarred colors like underglazes in a faster way to end up with blends that we can use in our art. And I thought I would tell you all about it. At the bottom of the screen, there's a couple things you might want to know about. The hashtag NCECA 2021 is going to be all over Twitter during the conference, and you should go look at that in between all of your activities. And also that's my Twitter handle, which you should visit every now and then. And of course, there's my website. So there are a number of questions that I'd like to cover in this talk, and here they are on the screen. And I figure I'd probably better cover what's the point. What we really want to do is get more color blends out of our jars in the least amount of time. But why would you do that if you only buy certain colors at a certain time? So I want to show you a really quick hack that I came up with that you can do with just clay and some simple tools. And I'll explain why it works later, but let's see what happens. The first hack is to roll out a slab of clay and come up with some way to make grooves. Here I used a paper clip. And as you see in these other pictures, I basically made some number of grooves. I don't even know how many there are. And I took some index cards and I made a slash down through the middle of them and pushed it into the clay. And then I took little containers of each of my glazes and poured them up to the index card on both sides. So here we're creating the slices and filling them. The next thing you want to do after you get those two colors all put in is to pull up the index card and mix what is in each of those troughs, each of those slices. And in the bottom left, you see that sometimes you can tell the color change and sometimes you can't because this is the wet stuff. And the last little section here is to show you the raw colors and then the fired colors. So you can see that between this particular blue combination and particular green combination, there's a few up in there that you might like, but you might look at this and say, well, I'm glad I didn't do a whole lot of measuring time because there's not a whole lot of difference between them. And that's the main time-saving idea among these hacks, is that if you don't happen to know how strong are all of your colors, this is still a really beautiful color gradient that you might want to use in your art. And so speaking of my own art, I really have a lot of fun with color and in different mediums. I've done a whole bunch of color testing in the normal way, and I like working with watercolors and different kinds of water medium. And I just wanted something that was a little bit more intuitive within the ceramic spectrum. And so I came up with these methods that I'm telling you. If you come from a design background, you're certainly going to have the idea of colorways. You're going to have a different way to come up with communication with your clients about how a different color should be and how many different colors are going to be in a range. And if you're into computers at all, you'll know that from this example, there's a nifty little application that I found where you could take two pure colors like that blue square and that yellow square and come up with any number of combinations in between, and the computer just spits it out. So why can't we in ceramics have this kind of freedom when we buy a couple jars of underglaze in the store? So the next question is, well, how much is it going to set me back in terms of my attention? I mean, everything that we've been taught is that it's going to be spoons or syringes or something, and what's going to happen? Where are the spoons and scales? Well, they're not really here. We all worship time in that big clock there, and it seems as though the only tools we have are scales and portions that we have to do manually. Well, the reason that we have to do that is that liquids get all over the place. They're basically sassy. They don't look like what they're supposed to in the jar. They don't look at it like anything until they're fired. They go all over the place, and that's why we have to use these gram scales and spoons. But that may not be the only way. What you may not realize is that liquids behave so consistently as volumes that I'm going to show you how they represent math if you can control what they do. They can be trained into shapes and be in different places and represent all of the mathematical things that we need them to be in our color blending exercises. And so the next question, a third question, is, well, how would we hack liquids? And so this is going to be a little bit of a thought about what kind of containers do we have to think about. So the problem with containers and liquids is that the liquid slooshes into a place, it goes where it wants, and then if you're not careful, it'll just go everywhere. But one of the overarching ideas about this is that a leak in this system becomes a portion. How you get it out of the system, how you change the divisions between the different partitions of liquids is actually useful. It's not a leak anymore, it becomes a portion. And so this array of shapes is just meant to represent the different kinds of simple shapes that one day we're going to talk about. All the cylinders and the rectangles and the wedges and the prisms represent shapes that we can move liquid into. And they also have a direct relationship to mathematical properties that we want our liquids to have when we blend them. So we're going to look first. We're not going to look at all these. We're only going to look at some of them first. Let's look at the cylinder first. This is a simple enough hack. You take a cylinder and you see the red dotted line. You fill it with liquid. Now, we'll talk about how sometimes you know that liquid or you don't know that liquid, how much it is. But here, 30-something straws were jammed into this. And when you layer them in this way and you push them all down and they capture the liquids, now you have a portion of liquid that is consistent through all of those straws that you can go use in your experiments. And for the moment, the contraption doesn't show you how they're caught in the straw. You know how you can put your thumb on top of a straw and hold it? Well, don't worry about that particular kind of element of the detail yet. That's going to come in a contraption discussion later. What I want to point out here is that once you set up these little contraptions, you're going to get a lot of math out of it in a hurry. Another contraption involves letting the liquid flow through straws before they're closed at an angle. The other was a whole mess of straws so that you could get equal portions. And the main thing that I want to talk about line blends here is that you want a series of different portions going gradually from larger to smaller. And the nature of liquid is to flow into tubes and level off. And that's what we're going to exploit in this discussion. So when all the liquid is moving around, there are people who've studied glaze chemistry quite a bit. There are people who study math quite a bit. And I'm sure some are asking, well, where is the math? What is happening? How is this going to work? Well, the liquid shapes are already math. And so the problem with scouting through colors is that you have to come up with all these proportions just to make the tests. And so my method lets all the calculations go last. You're going to do things with liquids in contraptions, and the calculations are going to go last if you need them and if you want them. And whenever you do find a blend you like, depending on what you knew ahead of time, you can go back and figure it then. You didn't have to know the numbers in order to perform the blends. You only need to know the name of it after in case you like it. Because if you remember that earlier tile, the differences between the blue and the green was so little that you might only want 2 or 3 of them, or you might not want any of them. It's like, no, the blue makes the green muddy or something like that. Well, the way you did it in those slices, you didn't have to waste any time with the scale because you didn't end up liking them. Or the other thing is also true. You could say, I'm so glad I did this because now there are like 6 colors in between the blue and the green that I liked. And then you go and name them because you knew how much was in the first slice of each of those colors. So only if you want it again do you have to do the calculations. And this is very convenient and completely backwards from what we're used to. And so now I'd better explain what is going on here. How actually are we going to create the blends? So this complicated sheet is as deep as it's ever going to get. Our line blend is usually a mixture of 9 parts to 1, 2 parts to 8, and so on. And if you looked at those numbers, you see that they could be represented by a triangle. And let's say you have blue and white. When the blue is diminishing, the white is increasing. And that's represented by triangles on paper that kind of represent the numbers involved. And they're all going to equal up to 10 parts. Depending on how strong is the color, the 50-50 of number may not be an optical 50-50 between your blue and your white, which is why you might well want to test them. The middle set of triangles is how we might add things together by intuition. You sploosh a whole bunch of glaze into a tray, and then you start messing around with your brush, and you're going at it by optimism and optics. And this also works for us. But you remember what you've done, and you remember what you've seen, and you haven't gone by numbers. Well, it would be hard to get help in an art studio if that was something that you did, but it's certainly how we work by ourselves. And the last set of the last graphic here is how we might do something by a recipe. You know, you're going to have things by portions relating to one another, or you're going to have portions relating to the whole. And so the math and the intuition of these things is all intermixed. And so my wedge concept is summarized by the letters fast, because in fact it is fast. If we could take the two triangles and do a couple things to them in terms of liquid volumes, you'll get some blends pretty quickly. So we're going to talk about how to fluff up a drawing and make it fatter, or flatten water down in a certain container. And so after that, you want an angle, because that's going to create the largest amount down towards the smallest amount. And then you're going to want to somehow create slices out of that, because that's our number of portions. And depending on how narrow you want your samples, your portions that the machine makes, you don't necessarily have to get them all, but you do have to trap them somehow. You do have to take them somehow out. And so that was how in the slices in the very first example, we scooched the color out onto the tile. That was taking them out. We happened to take all of them, didn't we? So let's look at angle. So in this idea of stairs, we see that an angle can be smooth, but it can be divided up by steps. And this numerically is like 9, 8, 7, 6, 5, 4, 3, 2, 1. And no matter however many you start, you're likely to do an equal number of them between maximum and minimum. And so this is how angle relates to the idea of the volume representation of our mathematical desire to have a series. And when you do two of those wedges together, well, that's a blend of them, and that's proportional blending between the two of them. And it sort of helps you think of a stair, well, going back and forth. And you see the little blue diagram there of two wedges, put one in front of the other. And then this is sort of a bonus slide, which might be confusing, and it doesn't have to be, and it's not completely important. But the whole slice idea is that you can use parallel lines to divide up a huge amount of liquid into very nearly any number of slices. In other words, how close do you want all of those differences to be? How narrow are those little stairs that you're stepping on? And so what you see is a block of brown, which looks like a block of wood. And sure, let's say that you want to cut up a block of wood into a number of slices, but you don't want to measure it. So here you put parallel lines down on a paper, and you angle the wood to where 7 parallel lines fit from one end of the board to another. And you're not cutting in the direction of those lines. You're using those lines to mark a position. You transfer the lines to the block of wood, and now you would then go ahead and use your saw. Well, sawing up a piece of wood is pretty similar to how we're going to be sawing up a chunk of liquid. And here you see that 7 slices is just as easy as 12 slices, is just as easy as an absurd number of 17 slices. You'd never want to take a board and someone asks you to make 17 slices out of it. You tell them to go get your own saw and do it. I'm not cutting 17. I mean, 16 wouldn't be bad, you know, because maybe it's a foot. So the concept of using parallel lines as slices into a volume of liquid is important, but we are not constrained by numbers in the way that we normally would if we were physically doing cuts or portions or something like that. And so, because when we make all the slices, we're probably going to make the device in such a way that there's more slices than we need. And like these library shelves that move back and forth and leave gaps, you can see in that little drawing down in the corner, you can make a bunch of slices out of the machine, but you only have to choose a few of them. And so the freedom of this method is that making the portions is actually going to be so fast that you'll probably make more than you need. And that's okay. I would rather that be the case. And so we go back to the idea that the computer could usually do things so easily, and then you just pick from them. Well, in normal use of spoons and scales and stuff, you wouldn't want to do all of that work, and you certainly wouldn't want to do all of that work when you didn't even know how interestingly those colors were going to work. So this saves time and leads to a bunch of colors that you might not otherwise have had. And so by now your brain is rebelling on many different levels. And I know myself that what I usually want to do is say, well, can I just do something? And so I wanted to free you up from any problems. Of course you can. If you want to use any kind of method that you used to use, you do that. You don't have to do anything you don't want, and you don't have to do anything that I am suggesting. But a lot of our methods have to do with basically tedious processes that perhaps we can work around. And so please react to this situation in whatever way that you would like. And so the last question is, well, where would we go from here? I mean, I've shown you that math relates to shapes and relates to color blending. And so what would we do next? So after the first example that I showed you, you could probably do a lot of your color blending already. You wouldn't need anything fancy. But what's next for me is that I'm going to be going through these different shapes. And we did talk about the line blend, and that happens to be represented pretty well by the wedge shape. But these other shapes, like the prisms and the cones and the things like that, actually become quite complicated into some of the fancy glaze blending and glaze chemistry things that we think about when we extend from the two line blend to the triaxial line blend to the quadraxial line blend. It's just insane how you'd want to go do it with a calculator and a scale. But with these types of fast methods where you flatten the liquid, you come up with an angle to the liquid, you come up with a way to slice the liquid into different shapes, and then take those slices as portions, you can do a quadraxial blend as quickly as you can do it, almost as quickly as you can do it a line blend, and get a lot of colors out of it. So what's next is for me to interpret these kinds of basic geometric shapes into contraptions that you might like to build. And one of them that's soonest coming is where we line up a whole bunch of straws and we fill the chamber with liquid and just tilt it. That gives the angle automatically. And so some of these are quite quick with things that you're going to have around the studio or can bring into the studio fairly quickly. And so overall, this idea of mixing colors all together relates a surprising interdisciplinary thing, because we're dealing with math in a way that's physical and not too challenging. I mean, not too scary. We're dealing with constancy of materials. We're dealing with a little bit of physics. There's a lot of conceptual programming going on because you need to think about, well, how are we going to get the liquid to stop? Well, that's like a circuit. And so a lot of your students who are interested in art are probably also interested in a number of these other things, when usually all you're thinking about is glaze chemistry and the stupid scales. And so I hope to show that this concept makes blending easier for the individual artist, but also makes exploration part of several other disciplines as well. Well, that is my presentation, and I'm so glad to have been able to share these things with you. The whole idea is that if you can trick liquid into being a certain volume and a certain shape, that you can get a lot of your math tedious tasks done a lot faster. And that's how I'm saying that they're not weightless. It's just that you don't have to measure weight every single time. So down there are, again, some information that you might want to use. Check out the hashtag on Twitter at NCECA 2021. While you're over there, you might say hello to me on my Twitter handle. And if you were so inclined, go visit my website where there's other artwork of different kinds of things. I've enjoyed speaking with you so much. And stick around, there's going to be a question and answer session soon. Goodbye, good luck, and let me know how it goes. Bye-bye.